Requirements for this section include understanding how to start a container and then basic TCP/IP networking concepts such as subnets and IPs and ports and firewalls. You don't have to know all that, but it'll definitely make it a lot easier for you to understand this section, which is focused on conceptual stuff before we actually get into a bunch of the command line stuff in the next lecture. So I just want to remind you about the -P option on your container run commands, which exposes the port on your machine. But there's actually a lot more going on in the background of Docker networking that we'll talk about. Docker has this concept of batteries included but removable, which basically means that the defaults are pretty easy and common to work with, but that you can change a lot of the options under the hood. And we'll quickly check out in this lecture the container port command that gives you a quick output of what ports are open for that container on your network. And then we're going to break down some of the concepts of Docker networking and virtual networks and how packets flow around the network. And we'll finish up with a network diagram showing how containers talk amongst each other and how that's different from the -P of exposing them onto the physical network. So when you actually start a container, you're really in the background connecting to a particular Docker network. And by default, that is the bridge network, as we'll check out in a minute. And then each one of those networks that you would connect to actually route out through a NAT firewall, which is actually the Docker daemon configuring the host IP address on its default interface so that your containers can get out to the internet or to the rest of your network and then get back. But we don't actually need to use the -P when we have specific containers wanting to talk to each other inside our host. So for example, if you had an application that had a SQL server and a PHP Apache container, those two containers should be on the same network and they're able to talk to each other without actually opening their ports up to the rest of your physical network. And if you had another application that was unrelated, that let's say was using Mongo and Node.js, you could create a network for that so that they could talk with each other without using the -P to expose them to the network, but they couldn't actually talk to the other network where you might have an unrelated app running. But the thing is that just about all those settings I described are actually changeable. And this brings up a good saying that Docker likes to use that is batteries included but removable. And you'll see that throughout this course that a lot of times there are defaults that just work out of the box. You don't even have to specify them. You just notice that things are configured in a sort of standard way, but a lot of these options are configurable either at runtime or even changeable after the fact. And we'll see some of that take place here when we play around with the networks. Some of the things that you can actually change would be creating multiple virtual networks, maybe one per app, or different ones based on different security requirements. And you can actually, just like in the physical world, have two physical NICs on a real computer. You can actually have two virtual networks connected to one container, or you can actually have the container talk to no networks. And you can skip any of the virtual network configuration that comes out of the box and actually use --net equals host. And you'll lose some of the containerization benefits, but in some cases, it might be required. And later on, we're actually going to get into Docker network drivers. And there's this whole plugin ecosystem around Docker that extends the capabilities of Docker to a lot of third-party tools. But in this case, we're going to look at a couple of different Docker network drivers and how they might change up our networking and give us new abilities. And this is really just scratching the surface. There's actually networking concepts throughout this course where we'll be talking about more advanced topics of multi-host private networking and concepts like sub-interfaces and so on. But for now, let's dive into some command line stuff. As a quick review, let's look at the -P of our container run command. So Docker container run. If you remember when we first ran a container, we used the -P to expose port 80 of our Nginx. And that took the left side, which is the host port, and forwards traffic from that port into the port 80 of the container. And if we did a Docker container port web host, it actually shows us in a nice, easy format which ports are forwarding traffic to that container from the host into the container itself. But we haven't talked about the IP address of the container. And so you might just assume that the container is using the same IP as the host. But by default, that's not true. And we can easily get the Docker IP of that container by inspecting it. And we're going to use the format command, or option really, which you'll notice actually has a pretty specific format for how to filter incoming stuff. Now you can always use the grep command, which we used earlier, to filter out your text output. But the format, the -- format, it's actually a little cleaner and consistent. So we do 2 curly brackets. And then once we get used to knowing the format of the config file, we know that network settings IP address is the actual node of that JSON output that we want to look at, and then web host. Oops, that means I didn't spell it right. IPADD. And that's not what I expected if I was going to use the IP of my host, because I know my MAC's on my local network, and if I do an ifconfig on my Mac, I just know that the IP addresses on my home network are a 192.168 subnet. So that's interesting that they're not the same network. So why is that? Let's see if it'll make more sense if I draw it out. So if my host operating system is connected to my network, so this is my network, physical network, and then this is the Ethernet interface on my host machine. In my case, it's my Mac. There's a little firewall in there that does several things, and it blocks all incoming traffic coming in from the network so that everything is blocked by default. So I would call it a firewall. And any traffic that's coming out from my containers is going to be natted by default. So it's acting like a pretty common edge firewall on a network. But there's this concept of the virtual networks, and by default, you'll see a network called Bridge or Docker 0. And when you start a new container, we'll call it C1, that container is attached to that network, that virtual network, and that virtual network is automatically attached to your Ethernet interface on your host so that it can get out. Now in our case, when we just launched that Nginx, we gave it a -P 8080. And that told it over here to open up port 80 on my Ethernet interface on my Mac and forward anything coming into port 80 through that virtual network to port 80 in that container. Now by default, when I create a second container, it's put on that same bridge network. And those two containers can talk freely back and forth on their exposed ports. But unless I specify the -P, no traffic coming into my internal networks here is going to get to my containers. Now I can actually create more virtual networks and call them what I want. So I'm going to call this one Net My App, let's say. And let's say I connect 2 containers here. I got a MySQL, and then I got an Apache. And on MySQL, I didn't open up any ports. I never specified a -P. But on the Apache one, I gave it a -P of 8080:80. That would mean over here on the right at my Ethernet interface on my host, it's going to start listening on port 8080. And as soon as traffic comes in to my host on port 8080, it's going to route it through down to this new virtual network I created and into that Apache server on port 80. But inside this virtual network, the Apache server is free to talk to the MySQL server over its listening port. So when you think about virtual networks in Docker and where containers belong, think about how you would put different containers in proximity to each other because they're related in their application. As you can see, these two examples, if I had container 1 and container 2 up top, running something different, if they're not going to be talking to the services in this network down below, then it would make sense to keep them on separate virtual networks. And if they ever had to talk to each other, they would have to go through their published ports all the way out and back in. And as a reminder, on any interface on your host, you can't listen on more than one port for multiple containers. So you can't have two containers listening on the port 80 at the host level. Okay, only one can do that. And if you tried to start another container, it would actually error out and say that there's already something else on that port. And that's not a Docker limitation, that's just a limitation of how IP networking typically works. So just a quick recap on this section. We actually spent a lot of time on the concepts of Docker networking, including the exposing of ports on your host to the physical network using the -p, and the idea of Docker focusing on sane defaults, where they call it batteries included but removable, and how for local dev and testing, you probably can just get by with the defaults, but everything is changeable. And then we learned about the container port command, which is a quick way to look at the ports exposed for your particular containers. And then we broke down the packets moving around virtual networks and how those relate to other virtual networks and how they get in and out of your Docker machine. So these are all really good concepts to understand as we jump into the actual CLI stuff in the next lecture. For this lecture, you need to understand some of the previous concepts around networking and also around creating containers. Now that we understand the concepts of Docker networking and how all the virtual networking and IP stuff works, let's look at some of the command line options for managing it. So first, there's the obvious network ls. Since we can create multiple networks, we surely have an ls command to list them. We have the usual inspect command, which you're probably used to by now from all the other inspecting we're doing, and that'll show us the details about a specific network. And then we have a create command that has an optional driver that we can specify for using built-in and third-party drivers to create a new virtual network. And then we have the connect and disconnect commands for changing a live running container so that a new NIC is created on a virtual network for that container. It's kind of like sticking a network card in a computer while it's running. So here we go. Okay, so back to my command line. And taking the concepts that we just learned, I can actually do a Docker network ls. And this shows me all of the networks that have been created. Now in this case, when you run the same command, you're probably going to see the same three. And depending on your operating system and version of Docker, you might see the bridge network called Docker 0 or bridge, but they both mean the same thing, which is it's the default network that bridges through the NAT firewall to the physical network that your host is connected to. And up until now, we haven't had to worry about it because all of our containers have just attached to that network and worked. But now that we have this Nginx container running, if I do a Docker network inspect the bridge network, you'll actually see that it lists the containers attached to that network. And you'll see that our Nginx one that we called web host is attached there. You can actually see its IP address. And you'll see up here that these networks automatically assign IP addresses, and it's showing you here with the IPAM config that the subnet defaults to 172.17, which is typically the default network for any Docker host, but it can be changed. And then the gateway for this network that will eventually route out to the physical network. And if we went back to the Docker network ls, we can see these other two networks. The host network is what we talked about before, that is a special network that skips the virtual networking of Docker and attaches the container directly to the host interface. And as you can imagine, there's pros and cons to that because it prevents the security boundaries of the containerization from protecting the interface of that container, but it also, in certain situations, can improve the performance of high throughput networking and get around a few other issues with specific special software out there. And then we have the last one of none, which is kind of the equivalent of having an interface on your computer that's not attached to anything, but we can create our own. So let's create a Docker network create my _app_net. All right, now we're going to do a Docker network ls again. And you'll notice that it created my new virtual network with a driver of Bridge. And that's because that's the default driver. It's a simple driver that simply creates a virtual network locally with its own subnet somewhere around the 172.17 and above, because it'll increment as it goes, so 17, then 18, 19, 20, and so on. And it doesn't have any of the advanced features that we might see later in this course, like overlay networks that allow private networking between hosts, and other third-party drivers like Weave. And if you look at the Docker network create command with help, you'll see that I can specify not just the driver that I want to use, but a lot of the IP and network options that you might need in an advanced scenario. Now, we can do several things with these networks and how we connect them to our containers. We can use the -- network option when we create a container. So Docker container run name new Nginx, and then network, and then my app net, and then the Nginx image. And if we did a Docker network inspect on the my app network, you would see that the new Nginx I just created is now on that network, and it has a new IP address of 172.18. So it's the next subnet in the list. But we don't actually have to start new containers, because just like in the real world where you can unplug and replug in Ethernet devices and reconnect to wireless networks, you can also do the same with existing networks and existing containers. And for this, we use the Docker network connect and disconnect options, and you can use -- help to see all the options there for Docker network. And in this case, what we want to do is Docker network, and we want to take the existing container that we created first and connect it to our new network. So I'm going to pick the new my app network, and then I'm going to pick the original web host we created. And now if I do a Docker container inspect of my original web host, you'll see that it's actually now on two networks, the original Bridge network, and I basically did the equivalent of giving it a new Ethernet interface on a different network with a different IP that was received from the DHCP. So we're now on the 17 network and the 18 network. And if I wanted to disconnect that, I could do the same with just disconnect. And then if I went back and did an inspection again, you'll see that it's now back with only the one network. So as you can see, there's lots of interesting options for Docker networking, and really the end goal here, and one thing I love to brag about with containers, is that if you're running all of the applications on a single server in this case, you're able to really protect them. Because in the physical world where we were creating virtual machines and hosts in a network, we would often overexpose the ports and networking on our application servers. So in these cases, if you were to take your app containers and have them all in one network together in a virtual network, you're only going to be exposing the ports on your host that you specifically use the -p with, and everything else is a little bit safer with that protected firewall inside their virtual network. Now later on, when we get into Docker Swarm, we're actually going to learn about multi-host networking and how this gets even better when we start to scale up and scale out. So to recap, we just covered a bunch of commands for managing Docker networks. We played around with the ls and the inspect commands, created a Docker network, and used the default driver of Bridge, so we didn't actually need to use the -- driver. And last, we tried out the network connect and the network disconnect commands for adding and then removing a NIC from a running container. Requirements for this lecture are that you've seen the previous network lectures and are understanding of the key concepts for Docker networks and the commands that go with it. All right, in this lecture, you're going to learn and play with DNS and how it affects containers in custom networks and default networks. And we're going to go over quickly how important it is that we have good DNS, because you can't rely on IP addresses inside containers since things are so dynamic. And we'll look at the differences between default and custom networks in regards to how they deal with DNS. And then we'll check out the -- link option for container run for enabling DNS on the default bridge network. So there's one more thing that's crucial to all of these containers and virtual networks and them talking to each other, and that's naming. Because in the world of containers constantly launching and disappearing and moving and expanding and shrinking and all the wonderfulness of these microservices that we're seeing crop up everywhere, is that we no longer can easily rely on IP addresses as the way to talk from one thing to the other, because we can't assume from minute to minute that the IP addresses are even going to be the same. The container might go away, or it might fail and then Docker brings it up somewhere else. It's just too dynamic and too complicated to deal with that. So it turns out that there is a built-in solution for this, and that is DNS naming. And Docker uses the container names as the equivalent of a host name for containers talking to each other. Now, if you remember, we just had 2 containers running. And if you remember, the new Nginx was on a new network called MyAppNet, right? And it has the one container on it. Now, because I created this new network that's not the default bridge network, it actually gets a special new feature, which is automatic DNS resolution for all the containers on that virtual network from all the other containers on that virtual network using their container names. If I were to create a second container on that virtual network, they'll be able to find each other regardless of what the IP address is with their container names. So let's try this. Docker container run name, and we'll call it my Nginx. And we're going to specify the network as my app net from the Nginx image. So now if we look at that network, we should see 2 containers. And if I do a Docker container exec from the new container I just created, oops, we also need the IT in there. And we do a ping to the new Nginx, you notice that DNS resolution just works. And this makes it super easy for you to have one container and you need to set a configuration file in it to talk to the, maybe let's say the PHP server talk to the MySQL backend. Control C out of that, and you'll see that it works the other way as well. If I jump into the new Nginx container and I try to ping the my Nginx, you see that the resolution works both ways. And this is what solves a huge problem when you're spinning up containers, because you can't predict how long they're going to last and where they might be a minute from now in a production design where you've got a cluster of Docker Swarm servers. So it may not change very much on your local machine, but if you stop 3 or 4 containers and then you start the same containers and you start them in a different order, they may not have the same IP address, but their host names or their container names will always be the same, and so you can rely on them. Now I should note, if we do a Docker network list, the default bridge network has one disadvantage here. It does not have the DNS server built into it by default, so you can use the -- link. So when you create a container, you'll notice there's a link option, and you can actually specify manual links between containers in that default bridge network. But really, it's just much easier to create a new network for your apps so that you don't have to do this every time. And in a future section, when we talk about Docker Compose, you'll see how so much of this gets even easier, because Compose automatically will create new virtual networks whenever you spin up an app with it. So communicating amongst your containers gets even easier. So just as a quick recap, we covered in this lecture about how containers can't really or shouldn't really rely on IP addresses for talking to each other, because they just can't be relied on. and that DNS is really the standard here for how we do intercommunication between containers on the same host and across hosts. And so I recommended you always create custom networks, since it's just easier that way than doing the -- link all the time. And then I gave you a teaser about Docker Compose and how it's going to make all this easier, especially the networking.